Hello, my name is John Dusing, and for my thermodynamics project, I will be evaluating this system, which is a propane gas grill, more known as just a barbecue grill. The five topics of discussion from Chapter 1 will be temperature. From Chapter 2 will be heat transfer, more specifically conduction and convection. For Chapter 3, we will be evaluating the propane in the propane tank, which is a compressed liquid. And for Chapter 4, we will be discussing, throttling, more so with the propane from the tank as well as in the grill. And finally, we will be talking about irreversibilities and what makes this process irreversible. So first, I'd like to talk about temperature. Temperature is very important when grilling. This grill has the capabilities of putting out about 48,000 BTUs per hour. Generally, the internal temperature here, read by the thermometer on the edge of the grill, gets up to between 300 and 500 degrees Fahrenheit. The surface temperature, where the meat is actually located, gets to between 450 and 600 degrees Fahrenheit. Temperature is vitally important, especially when cooking meat on the grill, because we want to make sure we are cooking meat thoroughly in order to cook out or destroy all of the bacteria that may or may not be located in there. So things like E. coli and other bacteria that I'm drawing a blank on right now. So poultry, what we are cooking today, we are cooking 4 breasts of turkey and 4 breasts of chicken. Generally, you'd like to cook this between 360 and 400 degrees to an internal temperature of 160 degrees to 170 degrees. This is generally a safe temperature in order to cook out all of the bad bacteria. From Chapter 2, we're talking about heat transfer, like I said earlier, convection and conduction. So first, conduction. The heat, conduction. The heat from the flame below is heating the grates up top. Actually, that is heated via radiation from the flames from the burner. Heat the grate on top, which then via direct contact cooks the chicken breast. So hopefully these guys are looking good. Nice. So via direct contact, the grill burner, the grill bars right here are cooking the chicken directly. Now, with convection, usually happens when the lid is being closed. So we close the lid here, and as you can see on the thermometer, it is about 300 degrees. So the air inside of the grill is heated and cooking the meat from the top side, as well as the meat being cooked from the bottom side from the grill bars. And now from Chapter 3, we will be discussing the compressed liquid propane. So a full propane tank weighs anywhere between 15 and 20 pounds. Generally, the pressure that the propane is kept at is about 100 to 200 psi. So in a normal, when you get a full propane tank, it is actually only at 80% capacity. They leave the extra 20% capacity in order for temperature change. So what you're not supposed to do is really leave it out in the sun, but if someone would leave it out in the sun, the temperature would increase and the pressure would increase. And so for safety purposes, they only fill it up to about 80% capacity. So stored in the tank, propane is at a compressed liquid state. When it exits the tank and goes through the system, it changes state to a vapor state because it is much less pressure outside of the tank. So from Chapter 4, we will be talking about throttling. So in this system, the propane vapor is throttled at two specific points. First, coming directly out of the propane tank, this is called a propane tank regulator. So this acts as a permanently fixed throttle, which cuts down that 100 to 200 psi down to about one half psi, and that is around the ideal pressure we want this propane flowing into the grill system. Second, the actual flames are controlled via the same amount of pressure throttling, but here at these grill knobs. So if we look up here from the vertical direction, you can see that the flames can be controlled. The flame size can be controlled with the knobs, turning it up to a full power all the way down, and a smaller flame with a smaller power. So the grill is using a throttling device at two separate parts of the experience. And finally, I'd like to talk about irreversibilities. So this is by far one of the most irreversible and common processes that you'll find in everyday life. First and foremost, cooked meat is irreversible. You cannot go from cooked meat back to raw meat. It is physically impossible. Second of all, we do not lose, but the mass, the control volume of the propane is converted to heat via chemical reaction, where the propane is essentially lit on fire. We add a spark right at the very beginning, which lights the vapor propane, which then changes it to heat and oxygen. And so at this point, we cannot turn that heat back into propane, which then goes back into the propane tank. That is a one-directional process. And And finally, when we open the lid, right now the lid is almost seals the entire grill with some small ventilation in the back and the side. But when we open the lid for an extended period of time, we lose all of that hot air, which we cannot force back into the grill itself from the outside. It is physically impossible in this manner, in this setup. So that is the gas or propane grill system evaluated on the 5 different topics which I expressed earlier. First being temperature and how important that is with setting the grill up and cooking the meat. Second, with heat transfer, how the heat is transferred to the meat from the grill via conduction directly from the grill itself and convection from the hot air inside of it. Third, we spoke about the compressed liquid which was located in the propane tank, which changes state to a vapor once exiting the tank and flowing through the regulator. We next talked about the throttling process, which is both throttled from the regulator that is attached directly to the tank, as well as throttling this flame size with the knobs out front. And finally, we spoke about irreversibilities and how this process cannot be changed back to its original state. Cooked meat cannot be changed back to raw meat. The propane which is burned to create the heat cannot be changed back to a compressed liquid or vapor. And finally, when we open the lid, we lose this hot air and lose that heat and energy out to the much cooler temperature of the atmosphere. Thank you for joining me, and that is my thermodynamics heat system.